Okay, sir.
Ma'am, you can start.
Okay, sir. Good afternoon, one and all. A warm welcome for day 4 session of the FDP, Emerging Trends and Technologies in Data Science, organized by the Department of Computer Science and Engineering, GMRIT, and Autonomous College, Srikakulam District. We are very fortunate to have with us today Dr. Ferddie Quiroz Canlas, sir, Assistant Professor, Department of Muscat College, Ruwi, Sultanate of Oman, to give day 4 session on the topic, Enough Apaches to Dig Big Data. I'm happy to give the formal introduction of the eminent speaker. Sir has 14 years of teaching experience in various colleges and universities, 10 years of administrative experience in colleges and universities as head of the department, associate dean, and even also as dean. 9 years of teaching experience in graduate school teaching master's degree with MSc IT, MSc Computer Engineering, and MSc in Big Data, and 12 years of software engineering, statistics, and research consultancy experience, and 4 years of full-time experience as head of the management information systems, and also 7 years of experience in educational quality assurance as commission on higher education regional quality assessment team member. And sir has many various fields of interest in data science, artificial intelligence, machine learning, software and network engineering, and IT project management also. And sir has the educational background of postgraduate certificate in teaching and learning in higher education from University of Stirling, and has done PhD in technology management with the specialization of IT project management from Technological University of the Philippines. And sir has past experience as Dean, Associate Dean from Philippines, and as a lecturer from Debar Berhan University College of Engineering, Department of Computer Science and Electrical Engineering, Ethiopia, and graduate and undergraduate lecturer from various universities and colleges in Philippines. And sir has current affiliations as Associate Fellow of the Higher Education Academy from UK, and he is the Microsoft Certified Innovative Educator. With this profile, I welcome you, sir, Dr. Ferddie Quiroz Canlas, sir, and thank you for being with us today for day 4 session, sir. With this, I'm handovering the session to you, sir.
Thank you very much, Dr. Vasudha Rani, for the wonderful introduction. And on behalf of Muscat College, I would like to thank and congratulate GMR Institute of Technology for this wonderful one-week international faculty development program on the emerging trends and technologies in data science. It is really an honor to be part of this event. Of course, this event is not possible without the efforts of the Department of Computer Science and Engineering through the leadership of Dr. A.V. Ramana, our head of the department, and of course with the initiatives of Dr. B. Santosh Kumar and Dr. Vasudha. And of course, dear audience, ladies and gentlemen, good afternoon to you. In this presentation, we divided it into 3 parts, as you see in my slide. The first part talks about the essentials of big data, its historical background, evolving definitions, nature, and what lies ahead of it. Also, all of us attending this event would like to contribute to the body of knowledge through research. So I took some few topics on research trends involving big data, not only for us educators, but also for our students as their graduation project. So these key concepts, if you will see mostly around 40 minutes of my discussion, the 30 minutes of my discussion will be discussing on the key concepts of big data, because these key concepts are very crucial and must be totally understood before we go with the tools. So as we know, tools are useless if we do not know where to use them. So we have to know the nature of how we deal with this big data before we go with the tools. So the second part of my discussion will deal with big data applications and tools. So we shall discuss the means and ways on how to store, handle, and manipulate and make the most out of big data. So these presentations will give you the eye view of all the available tools that we and our students can use to do big data project, or we can start our big data project. Actually, the tools I am discussing to you will take 1 semester each to discuss the intricacies and the details of this, but I'll be giving you the overview and the essentials of these tools that you can progress later on as you wish to study these tools. Because we have a lot of available tutorials and even references and communities supporting these tools. And I will give you the links later on as I go with this discussion. And the last part of this will only take a few minutes of your time, and we will talk about the challenges of big data. And of course, whenever we have challenges, we have opportunities, right? So we know for a fact that research comes into the scenario whenever there are challenges along our way. So to begin with, whenever we start the class in our Information Systems 101 or Database Management 101 class, we, or our teachers, start rolling the class with this question, which I call the classical question on what are the differences between data and information. And as you see scrolling in this, at the end of the class, you have around 15 differences based on the categories. These are the basic topics we are discussing during our introduction of databases classes. So you can start with the descriptions, formats, representation, meaning, interrelation, so on and so forth. And usually we end up the discussion by asking our students, or we give our students examples, concrete examples on the differences between data and information. But actually, we could summarize these differences into this. You can't have data without information, but you cannot have information without data. Why am I opening my discussion on this? As you go later in my discussion, you will be surprised that we are no longer dealing with simple data nowadays, but we are dealing with what we call big data. So, what is big data? Actually, there are varying, or may I say, there are evolving definitions of big data. If you ask an expert what is big data, if you ask a data scientist what's big data, they will not give you a high-cut definition of what is big data. But instead, there are various ways on how they define it. So I took 3 major sources, reliable sources and authorities when it comes to big data, and they gave us these definitions here. So there will be slight differences, but if you will notice, there are essential terms which I highlighted for emphasis, and they are giving us the big picture of what big data is all about. If you will notice, the first and the second definition talks about the nature and the way it is being produced. The last one talks about the structure and the usefulness or the potentials of BD as denoted by the term mined. Here comes that mining. Maybe you are very familiar with it, meaning getting something from something. That is why if you will notice in this title or in this webinar talk, the title is Digging Big Data. And we would like to enumerate in here the various tools on how we use or how we dig big data, because data mining is the talk of the town when it comes to big data. How do we get something from big data? I would like you to pay attention to the phrase difficult or impossible to process using traditional methods. So we have various databases tools as we teach them in the class. But data, as it evolved to big data, there is a must to go beyond the traditional database systems that we teach to our students. And we have to go further with advanced tools so that we could convert this data into a meaningful and useful commodity, which is the one I shown to you earlier. It's information. At the end of the day, our main goal is to produce information, something meaningful or something useful. But digging information is not enough. When we talk about big data, we are not concerned with converting data into useful information. In my discussion, you will see it later on. So on the middle of this presentation, we will enumerate and have the overview of these advanced tools I mentioned earlier and techniques in handling structured, semi-structured, and unstructured data. So in the big data concept, you're no longer pegged by rows and columns, fields and columns, as we call them in the traditional database systems, tuples, unions, something like that. And we are no longer much concerned with structured data alone. So you have to handle and produce gold. Take note of that. We have to produce gold from all the types of data available. And that makes big data challenging. And what makes big data challenging is the volume, the size of the data we are handling, and the rapid change. Big data means big work. That's why we have to know the tools. As I've told you earlier, big data has evolving definitions. A couple of years ago, maybe around the early 2000s, BD is characterized by 3 dimensions only. They define big data with the 3 dimensions, which we call the 3 V's. I give credit to Mr. Doug Laney. He's the one who coined the word, the term big data in the earliest 2000s. Also, we know these 3 V's, and they are the criteria to qualify your data as big data. What makes your data big data is these 3 V's. We call them the 3 V's. But as time goes by, these V's are actually evolving. If you will see, we have 3 V's plus 2 dimensions. That's the past one. But again, we evolve it. We have now the 6 V's of big data. We're no longer concerned with volume, veracity, and variety and velocity. But this time we are adding veracity, value, and variability. But for me, I think what makes BD useful is the last, the other V, which is veracity. Later in the succeeding slides, you will know why I give much emphasis to the last V. How to make BD, a big data useful is the last V. I have cited 3 major surveys conducted by 3 major IT organizations, and I will not deal much on this, as the graphics have shown to you here. So these 3 surveys, I took it from HP and the HR Boss. I think I have 3 sources of these surveys, although the figures are slightly different, but they speak the common thing, that big data comes from streaming data from the Internet of Things. Here comes Internet of Things as an ally field for big data and other connected devices, your mobile phones, your smart cars, your medical devices, your industrial equipment, and more. So another thing would be the publicly available data sources. They contribute much on the accumulation of big data. And of course, online shopping and online buying, they contribute a lot of data to our big data pool. And shockingly, if you will see the survey here, most of it come from you and me. Most of the big data, they came from you and me. How and why? Because 90% of BD, as shown in this screen, 90% of BD come from unstructured data, which majority of it come from social media. So if you if you will notice, this data stem from interactions on Facebook, YouTube, Instagram. Today, we are now contributing to big data because we are recording this webinar and uploading it to YouTube. So this includes a vast amount of big data in form of images, videos, voice, text, and sound, useful for, of course, marketing, sales, and support functions. If the organization is smart enough to dig on this, they could get most out of these things. So it means that, based on these 3 surveys, social media accounts have more contributions on big data. So it means that the more social media accounts you have, I think everybody will agree, we have 2 or 3 social media accounts, right? So meaning we are contributing to BD. But my question, and let me leave this to you as a challenge and maybe as an area for research, if you want to, this is the big question I would like to ask everybody listening in this webinar. Is your contribution to BD via social media useful? Or can we take something, or can we mine something from your post or from your contribution in the social media? So that's a big question I would like to pose to everybody. And we know for a fact nowadays the big challenge in the social media is the proliferation of fake news. So it's a very good research area also, how to help social media people to contribute into the big data. So in 2013 alone, big data went big. Okay, so many articles and white papers were citing a lot of talks and giving a lot of talks about big data. It's a talk of the town nowadays. So the phrase is now very popular, and you will hear many people talking about big data, and a lot of universities and colleges are offering courses in data science and big data. Our college itself, Muscat College, is offering MSc in big data, and I am one of the professors teaching this this module, and I am dealing with the tools and also with the machine learning part. So it's a new trend. And I think if your college or your institute is planning to integrate data science as an elective or one subject or one course in your curriculum as an elective, as I mentioned earlier, I think my presentation will give you an outline, and I think my presentation will be enough for you to have an outline. What are the things, the necessary things your students will know when it comes to big data? By getting my presentation as a guide, it will give you an idea how to structure your course if you want to offer it as an elective. So big data. So what? So let me cite one. Let me call it model from Bellinger in 1987. So this guy coined this model. Proposed this model. The main purpose of how we convert data into wisdom. So as early as 1997, our concern with data is no longer about converting it into information, but how we reach the top of the pyramid, which is how we convert data into a useful, wisdom. And let me change it. I changed this. Instead of data, I changed it to big data. Then we have wisdom. Now, looking at it, if having merely simple data, we could generate wisdom, what more if we have big data? I think on the top of this pyramid, I think wisdom is no longer the top of the pyramid nowadays, because we're no longer dealing with big data. With ordinary data, but we are dealing with big data. I think on the top of the pyramid is no longer wisdom. Let me borrow again another model from Carpenter and Kennedy, which is proposed in 2004, a way earlier when we proposed big data. That's why you will see in his model, he is also using the term data. If you will see on these 2 paradigms I've cited to you, the nature of data is evolving. right? And also the things that we can dig or we can get from this data is also evolving. With the Carpenter and Kennedy's model in 2004, wisdom is now a way lower on the top of the pyramid. We have vision, okay? Again, let me change it, data into big data. We are no longer concerned with just producing vision, but instead we want to produce strategies that will help organizations to achieve decision making. And of course, with good decision making, organizations can now achieve competitive advantage against the competitors. This is the main goal of every organization, dear friends, we know that. And this is the research trend nowadays. If you will see, most of the papers in the internet are talking about making data-driven decisions. So these are the research files I'm seeing most articles, especially in the management science area, in the business management area. They now try to get the power of big data to support organizations to make data-driven decisions. And this is the focal point why we have big data. So let me just share to you some quotable quotes. Maybe you know this movie, Sherlock Holmes. He says, "It is a capital mistake to theorize before one has the data." And I agree with this 100%. And maybe the second quote is a joke, but it makes sense. It says, "In God we trust, of course, but all others must bring data." And I agree with this, from Sir Edward Demings. It means nowadays, for you to be reliable, you have to bring more data. That's why I was really amazed Dr. Vasudharani read my brief wholly, but I did my best to give you the brief as I could, because if I give you the entire CV of mine, it will take around most of the session time will be spent on that. But I am really happy that Dr. Vasudha really read all of those. And from Charles Babbage, errors using inadequate data are much less than those using no data at all. I agree with this also. And from the management perspective, what gets measured gets managed, from Peter Drucker, the famous management guru. And let me inform you, my friends, that the US Chamber of Commerce nowadays, they consider data as a resource. It's fact number 7. They say data is a resource, much like water or energy, and like any resources. So it's now one of the resources. We consider it as a resource. That's why we have now this what we call data economy. So I have big data. What makes it sensical? Does it mean if I have big data, I have bigger enough? The importance of big data actually does not revolve around how much data you have, but what you do with it. We don't care about if you have petabytes of data in there, but if you don't know how to transform it into something useful, and then that data is actually useless. So nowadays, big data is being used for data-driven decisions I mentioned earlier, to help organizations to develop their product, like Netflix and Procter & Gamble. Netflix and Procter & Gamble are actually the beneficiaries of big data nowadays. They improve. They can get the preferences of customers using this big data, and also automated predictive maintenance. So using your accumulated record of your mechanical failures in the industry, you can predict what are the possible times and days a machine may shut down or shut off, and from there you could make a predictive plan. So those are very good area for research actually. And you can improve customer experience using big data. a lot of researchers on sentiment analysis. We hear them there and there. So this contributes to the customer experience, how we do with it. And nowadays, big data is being used for fraud and compliance, especially banking systems, security systems, or they are insurance systems. They are using big data for fraud and compliance, and of course, machine learning. So we know the more data we fed on our machine learning, it becomes more intelligent. And the more it becomes intelligent, the more automation it can produce, and the lesser the human intervention. And this one, drive innovation. So with data you have, you could drive innovation. But what is in the middle? In the middle of it, we have analytics. So meaning, to convert big data into useful decisions, here in between is analytics. And analytics is not talking about tools alone, which I'm going to present to you, but how we use those tools to arrive decisions. Meaning, analytics is just a tool to achieve our use case and the contexts on how we want to get something from big data. So again, these are good areas for research. All of this phase, or each phase that you see in my presentation, are good area for research actually, with the advent of big data. So for the management perspective, set a big data strategy. Again, it's a fertile research, how we set big data strategy. Identify big data sources, another fertile area for research. Access, manage, and store big data. Analyze big data. Again, it's a very good research. If you will see every minute of the day, you will be shocked. A lot of tools are available for big data. As long as big data is the talk of the town, you will expect many tools are being introduced every now and then. And I myself, I was shocked because last semester I have installed the latest tools in our laboratory in Muscat College. But now when I open the internet as I am doing this presentation for you, I was shocked that the tools I'm using were actually passé. They are old, and the versions are old, and I have to update them. For what reason? Of course, security. We need to secure data, and that's one challenge we have to look at. So in the big data analysis, again, there are a lot of processes that data scientists, even us educators, must have to look into and take this and convert this into as opportunity for us to do research. So big data analysis takes many phases. Okay, I'm talking alone on big data analysis. I'm not talking about the other phases. On the big data analysis alone, we have sub phases again that are fertile environment for research. And there is a lot of money, even funding, for big data research. If you will see in this slide I'm showing to you, companies are spending big on big data. So expect a lot of funding. Even government agencies are spending a lot of money on this. So a lot of money are being spent on big data. And I think my source is, I think it's US alone, if I'm not mistaken, it's US alone. But look at the global perspective, how much money is being poured into big data. That is why data science, or being a data scientist, they call it the sexiest job of the 21st century. And I think most of you have read articles from the Harvard Business Review back in 2012. So they call it now data science as the sexiest job of the 21st century. Why it is the sexiest job? Obviously speaking, look at the abilities that the data scientist should possess, and also who are the people working with you. If you will see, data science is the amalgamation of all the fields. right? And all of them are pointing towards to you as a data science. That's why you have to work with a mathematician, you have to work with a machine learning expert, a computer scientist, and a data analytics, a person. So you have to work with these people because data science is a domain which is connected to various domains. That's why they say being data science is really challenging. It's really hard to become a data science because you have to know each area. For you to be able to communicate with a computer scientist or an IT expert, you have to know the domain of computer science, so on and so forth. But don't you worry. The good news is you don't have to worry about much about this, how to handle these things, because there are a lot of resources and documentations provided by each tool that you're going to use. And I'm going to present to you this time. A lot of YouTube tutorials and everything. That's why if you will see, I did not prefer to give you a hands-on here because it will not make sense giving you a hands-on during this webinar. But instead, I give you the essential things that you need to look at, and later on you can progress on your own. Actually, that's the purpose of learning, right? Knowing the essentials and then progress later on. So these are the research trends in big data, and most of my students in Sterling, University of Sterling, we are dealing much of these areas on the research part, mobile and real-time data, and artificial intelligence, and of course the one I mentioned earlier to you, security. So this is the biggest challenge when it comes to big data, security, how we secure our data. So this is a fertile area for us to do research. Now let me go to the next half of my talk, which is about the big data tools and the applications. So we have plenty of big data tools, and most of my students in the master's degree are using these tools. I've installed all of this in our laboratory here in Muscat College. But what I could say is that the learning curve for these tools are not difficult. I mean, it's not stiff because a lot of resources we could get from YouTube and also from the developer themselves. They have communities that support users on how they use this one. But the major challenge I have faced with these tools actually goes on the installation, the administration, and the management of these tools. It's really challenging because most of these tools, they run efficiently and securely in the Linux environment. So an in-depth knowledge of the Linux environment, specifically on the command line, is required for you to be able to administer and to install these tools. So before you go with the tools, we have to know first what kind of data we are dealing with, or what kind of big data, or what is the nature of the data, or what are the nature of the data we are handling. So we have the unstructured data, we have structured data, and we have semi-structured data. So if you are working with structured data with columns, rows, fields, then databases would be enough. But if you are working with unstructured data, then you have to go with Hadoop, the Hadoop environment. And if you are working with the semi-structured data, also Hadoop is very fine with that. So meaning the tools that we're going to use is based on, of course, what kind of data we are handling and the context, again, the context where this data are to be applied or used. I think yesterday there's a similar talk about this talk, and I appreciate that. Our dear doctor have discussed something about HDFS, and he made elaboration on the HDFS. But in this talk, I won't elaborate much on that because I want to give you only the essential points that will be very useful for you and you can use as a starting point in your journey towards learning a data science. So the Hadoop ecosystem is not a programming language. Please make note of that. It's not a programming language, okay? It's not even a service. Actually, it's a platform. It's a framework. It's a base. It's a base. It's like if you look at a house, it's a structure, the main structure of a house or a building. So it's a framework. And you can consider it as a suite which encompasses a number of services, okay? So it's a baseline wherein you install later on additional things. If you will see in this slide here, we have different add-ons, right? We have Spark, Storm, Pig, we have Hive. So we have all of this. But the moment you install HDFS, I mean Hadoop, I'm sorry for that. The moment you install Hadoop, these three major components will be installed. We have HDFS, Yarn, and MapReduce. Hadoop is not HDFS. Let's make a clarification on that because most students are mixing the two. When they say Hadoop, they are referring to HDFS. HDFS is a component of Hadoop. It's a file system. It's like if you want to install Hadoop, then you have to have HDFS. It's similarly, if you want to install Windows 10, it requires NTFS. So NTFS is a file system and Windows 10 is an operating environment. Likewise, HDFS is the file system and Hadoop is the operating environment wherein you install later additional tools, which I'm going to discuss to you later on. Yarn is another component installed. It helps administrators like you and me in monitoring and troubleshooting your server. So Yarn is an environment wherein it will give you an eye view what's happening on your system. It also gives you idea on the resources being taken by its job that you submit to your server. And MapReduce, I could call it, it's a built-in language that, that you could use to write MapReduce programs, and later on I will discuss to you. So this is built on top of Yarn. The moment you install Yarn, MapReduce is also installed. So this is, I could say MapReduce is the primitive tool that you could perform or you could use to query or to work with big data sets or data sets in your Hadoop ecosystem. So the moment you install Yarn, MapReduce is also installed. So basically, MapReduce is the primitive or the essential components of the Hadoop ecosystem. And it works directly with your Hadoop server. So Hadoop has this very powerful file system, which is the HDFS file system. And it has many assumptions. So I think yesterday, if you attended the session of our dear doctor, I think you are made aware of what is HDFS and the assumption and the purpose why we have this this one. But I want you to look at the architecture. So the main problem with big data is that we are no longer storing megabyte, gigabyte, and terabyte of data. The biggest challenge on big data is actually how we store petabytes of data. That's a big challenge that we are facing nowadays. We have huge amount of data, petabytes in a day, actually, even in a minute. We have petabytes of data we are collecting. So the problem is that where to store them? That's a big question. Because as far as I know, I think our hard disks nowadays, we have terabytes. I think as of the moment, the biggest storage we could have for our machines are terabytes in the size, but we are storing petabytes. And not only that, in a day, we are storing petabytes. So the solution to that is the HDFS. What we are doing here is we split the data and distribute it. That's the purpose. That's why if you see in the caption, if you cannot contain it in one storage, you have to distribute it. That's the purpose why we have the HDFS, the hadoop file system. So it's a slave and master architecture. You know, maybe you are very familiar with slave and master architecture, and it is quite similar to the existing architecture that you know. And the main goal of this one is actually to distribute your data into the available resources you have in your laboratory. In my case, in Muscat College, what I have done is I configured I think two secondary nodes, or what do we call the data nodes, and one name node. In the they are the Linux ones, and also I use all the available computers in our lab as slaves. So meaning you can configure your available machines. If in your laboratory, in your college, in your institute, you have, let's say, for example, 1,000 machines, then you can configure all of those to be data node. Then you could distribute all your data into that one. So that's the principle of Hadoop. So Hadoop will divide your data into smaller pieces and replicate it. When I say replicate it, it will make a copy of your data to the machines configured as the data node. So depending on your configuration, you could configure your Hadoop to chop data, let's say 128 megabytes, depending on the sizes or the available resources you have in your lab. You could configure your Hadoop to chop. Initially, by default, we have, I think, 128 megabytes as the chopped data you have, and then this will be redistributed. And also the replication, again, is based on your configuration. If you want to replicate your data 2 times, then you could configure it during installation. If you want to replicate it 3 times, it's all up to you. You could modify it later in your yarn configuration, the size of the chopping, and also the number of replication. So my students in Muscat College, they are accessing our Hadoop using Apache. This it's a terminal. It's an SSH terminal, and students can access the HDFS. By the way, HDFS, you could access the HDFS using a command line interface. It's similar to your command prompt. And if you are very familiar with Linux file system environment, you will not find it difficult to work with Hadoop because most of the commands are very similar. You will see it says mkdir, make directory, meaning you want to create a folder. So HDFS is following a hierarchical model like our typical file system. Okay. So on the user perspective, you see the data as though they are on a single location, but the truth is your data is spread across your available machines or storage in your network. So if you are good at Linux command lines, you won't find it difficult to work with HDFS. The only difference is that in your command line, you have to affix this first 2 keyword here, which is HDFS, DFS, and then put a minus sign to your command. And then let's say, for example, you want to you want this coffee.txt to be copied to your HDFS directory. You could go with this command, copy from local. If you want to see, or if you want to list the directory, you can go with the ls -ls. So if you have written your MapReduce code in Java and you want to compile it, so you could compile it with your Hadoop command like this. Then if you want to convert your your MapReduce code in Java into a jar file, then you could execute this command. And if you want to run your MapReduce code and you want to process this data, which is coffee.txt, let's say, for example, by the way, I love coffee. That's why my example is coffee here. So if you want to process this text, and then you could run this executable file you have written, and then you could store the results on a directory called results. And if you want to read the content of the result, which is usually on this form, then you could run the cat or the cat, and then you will see the result of your MapReduce program. So if you want to delete a directory, it's very simple. You can run the rm. So as I've told you earlier, it's very similar with the Linux environment. It's not difficult for us to migrate into the HDFS file system. So if you want to download this, and if you want to deploy it in your laboratory, you could get this in this link that I have provided to you. But there is this one website. If your college is not capable on installing all of these tools I'm going to discuss to you, you can go with this website at the bottom of my presentation. So it could give your students 15-day free access to Hadoop online. So all of the tools that I'm going to discuss were already installed on that website, so you don't have to install them on your own. But if you want your students to have unlimited access to your Apache softwares in your Hadoop ecosystem, then I suggest you have to install it on your own. So who loves Java here? During my class, whenever I ask my students to write MapReduce program, most of them are complaining on the Java because, you know, Java is really challenging, not only for us educators, but also for our students. So MapReduce, it requires you to know Java, enough Java to MapReduce. So it's a software framework and a programming model as well for processing huge amount of data. So MapReduce program works into two phases, map and reduce. That's why we call it MapReduce. So the map task is dealing with the splitting and the mapping, and the reduce is on the shuffling and reducing. Hadoop is capable of running MapReduce programs written in various languages like Java, Ruby, Python, and C++. But mostly Java is enough to do it in the laboratory, because I think most of the laboratories we have installation on Java. We have mostly Java-based programs, so installation is not a problem on that. If you want Python and Ruby and C++, you have to install a third-party software for that and link it with your MapReduce. And be careful when you install Ruby, Python, and C++. Complications may come along the way. They might not communicate with your Hadoop ecosystem. So better start teaching your students Java. If they are comfortable with Python, they could go with Spark later on. So I think you're very familiar with this. Most of us are very familiar with this. So the crux of the MapReduce, of course, the two functions I made mention earlier, map and reduce. So they are sequenced one after the other. It means you cannot go with the reducing if you're not done with the MapReduce. So meaning students are required to write MapReduce, map functions, and reducing functions. So which should make them a little bit challenging. So your data input here may be a text file. It could be a comma separated file or CSV file. And then what happens is we split them. So the size of the split, it depends on your configuration in your map, in your yarn. Again, as I told you earlier, in your yarn, you have to configure your MapReduce to tell the splitting. How do you do the input splits? And then if you have, let's say, for example, 100 records to be processed, so you will have 100 mappers to work together to split that. or you could, or maybe 50 mappers, depending on your configuration. As I've told you earlier, you could go with one mapper, one record during splitting, or one mapper, two lines or records. It's all up to your configuration. Then after this, you can go with the mapping. Okay, if you will see in the mapping here, we are starting to, after, let's say for example, we have individual mappers here, then you have to count the occurrence of the texts or a keyword that you want to search. Later on, I'll give you an example for this. Then you could count it in the mapping stage. In the reduction, you could have this, here, you will see, you have the shuffling. So in the shuffling, it's like we are sorting, or we are, aggregating all of this. Then after that, the reducing phase, you will be having the total of the occurrences of the words. But sometimes there are situations wherein you want to do more on your data. Let's say, for example, you want to take the average. You just don't want to count, let's say, the occurrence of the word. Let's say, for example, you want to group them. And then after grouping, you want to get the total per group. Let's say, for example, or you want to take the average. So in that case, you have to introduce another component, which is the combiner and the partitioner. So combiner and the partitioner are then added, okay, into the scenario to perform advanced operations. That's why the MapReduce is very challenging to students, because they have to design their MapReduce program in order to achieve what is being given in the case study. So if you ask your students to take the average or the sum or the group or group the data, and then students will really find it difficult to improve their MapReduce programs. That's why in the master's degree program, I'm asking students to write 3 versions of their MapReduce program design, and then from there they have to identify the strengths and weaknesses of those versions, and they have to calculate statistically the execution time and performance of each MapReduce code. So since we are writing code in the MapReduce in Java, you could get a lot of versions on your MapReduce program. But don't you worry. We have useful MapReduce websites. I suggest, and usually I tell my students to go on this website, the Hadoop Apache. So Apache has a documentation on this, and there are a lot of samples you will see on how we could do the MapReduce. And even the source code for the MapReduce is there in this website, and you could just simply modify it depending on your needs. So meaning students should have an in-depth knowledge on how to revise Java code to suit the case study or the context wherein MapReduce is being written into. So the MapReduce actually is very useful for me in doing word count. Let's say, for example, if you're working with a sentiment analysis project, then MapReduce is enough for you to work on that. And you can count the words that you like, and also you can revise this MapReduce code and exclude some words. Let's say, for example, you don't like negative words, like cursing words. Let's say, for example, you downloaded one file from a social media account and you want to get the perception of the people on a specific issue, and you don't want to count cursing. So you could exclude them. Let's say, for example, you want only to count one specific word. You are only concerned with these words, and you don't care about the other posts. So you can go with the include, and you could revise your MapReduce code and put that those include words. So you could write your MapReduce program here on one text file, save as Java, and then you have to put your include words or exclude words on another text file and call it later in your MapReduce program and run it in your Hadoop. So this is an example of how you execute your MapReduce code. So if you have mistakes or errors in your MapReduce program, and then Hadoop will give you messages, warning messages, I mean the error messages why it's not running successfully. And then if you are successful, then you will see outputs like this. Let's say, for example, in the word count, bye, 1, goodbye, 1, Hadoop 1, hello, 2, world, so on and so forth. So you could count the occurrences of the word here. So if you want your students to work with real life data or real-time data, I could suggest you have to go with this website. Kaggle is on the rescue. Kaggle is a very useful website that help us to get real data sets. This is the common problem of my students in the masters. When they want to work with data sets, they don't know where to get the data. So Kaggle is very helpful. It's a website that provides all the necessary data sets our students may need. So in the laboratory last time I asked my students to analyze the sentiment analysis of the US airlines. So which airline is having most negative feedback from customers, and what are the common sentiments customers are having with this kind of airlines. So I browsed Kaggle, and you will see in here it says COVID tweets. You could get here some COVID. If you want to study on COVID, then your students can download data sets from here all over the world, and they can work with data sets involving COVID area. So we have plenty of it. And my students, we have this airline, and the data here are updated. That's good with Kaggle. They update the data. Because last time I've asked my students to download it, and one student downloaded earlier, and the students downloaded a week after, I guess. Then they have different sets of data. So they are updating the data every now and then. So again, what makes MapReduce challenging for you and me, and also to our students, is the in-depth knowledge of Java. But if you hate Java, we have another tool which is very useful, which is Apache Hive. And I think you will love this very much. For those who haven't, who are still migrating from the traditional database management systems like MySQL, MS SQL, Oracle, you don't have to worry, okay? Because Hive is a bridge between that. So Hive is actually a very useful tool if you want to work with structured and semi-structured data in the Hadoop. So likewise, same thing, you have to go with the first thing, you have to store first your data to the Hadoop HDFS before you could have it with Hive. So Hive is a very good substitute for MapReduce if you're not good at writing Java code. Then Hive is very useful. So it is using a language called HiveQL, which is very, very similar with SQL statements. You will see it later as we go with my presentation. So if you will see in here, we have Hive in the middle, and then we have the Hive server, of course, installed on top of the Hadoop ecosystem. And then Hive will convert it into a MapReduce code. Okay, so you don't have to worry about writing your MapReduce code. Instead, the Hive server will convert your SQL statements into a corresponding MapReduce code. So you don't have to worry about it. And then it will be executed in your Hadoop server. It will return the data to you. So Apache Hive was actually developed by people from Facebook, you know it, and they surrendered it later on with Apache as an open source project. because the problem they encountered in Facebook is that in a day, Facebook is dealing with petabytes of data. And their problem is that it's really difficult to dig or mine those data using the typical MapReduce program. It makes life complicated. And running MapReduce is actually taking a lot of resources and time, depending on the size of the data, of course. So to give the Facebook users, I mean the technical people to the back of Facebook, they want to give a very flexible environment wherein users will not, I mean the technical people will not have to write again and again and again MapReduce code, compile it, and again run it, compile it, run it, compile it, run it. So they have created this this tool which is Hive. So as I've told you, if you haven't, if you are still on the traditional database management system and you are still on the transition between traditional management system and the big data applications, you don't have to worry, because the same knowledge that you have learned from the traditional database management systems are still applicable with the Hive server. If you will see the syntax are the same in creating database, you will see it says create database, very similar with the syntax in MySQL, right? Yeah. So Hive is basically patterned with MySQL, because in fact Hive is using MySQL. Later on I will discuss to you. So when you create a table or when you create a schema, as we call it in MySQL, same syntax, if you will see it. But Hive is introducing this what we call partition and cluster. Okay, so partitioning and clustering. So unlike with our typical MySQL database, we know it, right? Data are represented in rows and columns like this. But in what do you call this one? In Hive, you can actually partition your data, okay, to speed up the query. Let's say, for example, in a typical MySQL table, all of the data are arranged the way they were inserted, right, in the sequential fashion. So let's say, for example, you have let's say, for example, American Airlines, Canadian Airlines, Indian Airlines, for example, like that. So all of the information were inserted according to the order they were inserted. But in I mean, in the MySQL, if you were going to query, let's say, for example, you want to select only all the Indian Airlines sentiments, what will happen is that the query processor will have to scroll, I mean, explore the entire schema and return the values that you are looking at. But for Hive, you can actually pre-process your data using partitions and cluster. So what you will do is, let's say, for example, you want to put Indian airline sentiments on one directory, you call it partition. Or again, if you want to cluster it, let's say, for example, positive comments, negative comments, you can pre-process like that. And then another folder for, let's say, for example, Oman Air, like that, or the airlines. And after that, when you do the querying, querying in Hive, let's say, for example, you're querying about the Indian Airlines, Hive will not go to the other folders that belongs to Canadian Airline and other thing. It will just simply go to Indian Airlines subdirectory and query that. So meaning the latency will be reduced. So since it is file-based, you have to remember, my friends, this is Hive is file-based, meaning you have to load Excel files or CSV files and text files on your Hadoop, and from there you can query them in such a way. I mean, similarly when you query with a MySQL database. So when you load the data, it will be like this, as I've told you earlier, and after that you could do the querying later on. Let's say, for example, you want to count the tweet ID from tweets grouped by user based on time zone. So you can do like that. Very, very, very friendly environment. My students are enjoying much on Hive when they go with the hands-on. So if you want to download Hive, you can go with this website and you could download it from there. Good thing with Apache, they provide also the necessary documentation for you to utilize this and how to install it also. So we have another Java hater. If you really don't like Java, but you want more flexibility with your work, then you can go with Pig. So Pig was introduced in 2006, I think. I mean, it was developed in 2006 by Yahoo. And at that time, the main idea to develop Pig was to execute MapReduce jobs. Same thing, same problem experienced by people at Facebook, writing MapReduce code in Java. Again, it's their challenge. So to eliminate that, they introduced another environment, which is Pig. So Pig is a high-level scripting language. And it is having an environment like this. So Pig is operating the same manner as the Hive server. So it has an environment like this that converts your MapReduce program into, I mean, your Pig Latin scripts into the MapReduce. One advantage of Pig over Hive is that you can embed your Pig Latin scripts into other programming languages. So if you are concerned with visualization on how you present your data, actually you can invoke your Pig scripts to Ruby, to Python, and to Java. So if you are writing some interfaces for visualization. But then again, Pig is also dependent on the Hadoop environment. So you have to load again the data to the Hadoop, the HDFS, and then you could access your Pig using a command line. Same with Hive. So both of them are command line interface. So you have to deal with a command line, a command prompt like interface, and from there you have to write your scripts and your query. So it is using a grunt shell, and it has a parser, an optimizer, and a compiler. We know this one. If we discuss the database environment with our students, we know what's a parser, optimizer, and compiler. So basically, and after that, it will be converted into a MapReduce program. So these are the sample syntax that we could encounter with Pig. So if you will see, Pig is having shorter numbers of codes or line of codes comparing to Hive. If you will see, loading and creating your schema is very straightforward when it comes to Pig. I just took the same what do you call this one, use case. Okay, so the creation is very simple, just like this, and then storing your schema. You can save your schema into your directory inside Hadoop. Unlike Hive, the schema of Hive is actually dependent on a third-party database system. So Hive will store the schema to the MySQL server or with the Derby database. So you have to install a third-party database to store the schema or the metadata of your tables, as we call them in the traditional database systems. But for Pig, you don't have to do that. So Pig itself can store it into the directory where you have created. And also, if you will notice, in Pig, you don't have to create a database, because a folder or a directory in your Hadoop is considered to be your database, the instance of your database. Unlike in Hive, as you've noticed earlier, you have to create a database name, and that database name will be saved into the MySQL. It means that if MySQL is not installed, and then Hive will not work properly in the execution time. So same manner, we have describe. If you want to the name of the table here, if you want to describe it, and if you want to illustrate it, illustrate is a better one. Illustrate, it will give you a graphical user interface like with rows and columns. Like when you go with your MySQL command line, you will see the name of the field and the data type like that into a row and column format. In the explain keyword, it will give you a lot of detail, very detailed description of your table. In the describe one, it will give you a brief one. The most essential information about your table will be given to you with not much intricacies. And if you want to display the contents of your file, it's similar to your select from. You can go with dump tweets, the name of the file you want to, the name of the table. If you want to display all the rows and columns, just type dump tweets. And then if you want to do some groupings, then you have to write code like this. Group data, it's a subtable. That's why it's a streaming programming language, right? It's a streaming programming language. You will see if you want to make a group, let's say for example, group tweets by user time zone, and then you could save that into another sub schema, and then after that you could illustrate group data. So what will happen here is that it will display to you the result of the group data into rows and columns with a drawing. So these are the common thing that you will see. Many might say, wait, Pig is like Hive, but there are major differences, okay? So on the basic ones, Apache is using a language called Pig, Latin. It was originally made by Yahoo, and Apache is using Hive QL, created by Facebook. So Pig Latin is a data flow language, okay? And then Hive QL is a query processing language. So Pig Latin is procedural and Hive QL is declarative. So I don't have to discuss this to you. These are common terminologies that we all know in our programming classes. So Apache Pig can handle structured, unstructured, and semi-structured, although Apache Hive can handle unstructured data, but Hive is very best for situations where you are dealing with structured data. Meaning in the Apache Hive, if you want to deal with semi-structured and unstructured data, you have to pre-process them, as I've told you earlier, using buckets and partitions, the one I told you earlier. Okay, you have to pre-process the data and load it in your Hive server. So it is very efficient if your data is on the structured data, but in a form of CSV files, text files, and even documents. So Apache Pig is used for programming, of course, and then Apache Hive is used for creating reports. If your concern is much on creation of the reports, then Apache Hive is good on that. Apache Pig is used by researchers and programmers, and Apache Hive is used by data analysts, the end users mostly, which are lacking much programming skills or knowledge. So Apache Pig operates at the client side of the cluster. That's why it is quite faster than Hive, because on the Hive, it operates on the server, meaning we give a lot of burden on the server side, because it runs on the top of Hadoop. So Hadoop is also taking the burden from the Apache Hive. Lastly, Apache Hive relies on MySQL or other databases to store the metadata for the schema. So if you want to install Pig, Pig is available, and the documentation, also the tutorials are available on the Apache website. So you can go with this link. Now, I could say this tool is the most powerful among all those tools. Although we know for a fact that every tool has the pros and the cons, right? The advantages and advantages, the drawbacks and the benefits. But I could say Apache Spark is the most versatile one. That's why you will see a lot of tutorials, even videos, and even documentation, white papers, research papers are dealing much with the Apache Spark. Because Apache Spark is not only concerned with the MapReduce, querying the database, but also what I like the most with Spark, it's the machine learning part, the analysis part, the advanced analysis part of Apache Spark. So the previous tools that I have discussed to you are lacking these powerful components, which is the machine learning and the graph algorithms, because we know for a fact, right? Big data now and artificial intelligence or machine learning are intertwined, as you have seen in the graph I've shown to you earlier in the data science part. So we have plenty of advantages that we could get from Spark. So Spark is having this environment wherein you could invoke SQL if you want to work with a database like queries, select from and group by, order by. So Spark is still supporting that. It is using data frames and data sets. If Hive is using partition and buckets, Spark is using data frames and data sets. It is the default file format for Spark. But again, Spark can work with CSVs and other data formats. Don't you worry about it. But if you want the Spark to work very efficient, then you have to convert your data into data frames and data sets. And then Spark also is good for streaming, meaning real-time data. Okay, which is the disadvantage of the first three, MapReduce, Pig, and Hive, because Pig and Hive requires a data saved into a CSV file or into a compiled file and then feed it to the HDFS. So in the Spark, you don't need to do that. You don't have to even store the data into the HDFS. You can process it directly using your Spark. We call it the Spark streaming. And then this is the one I like the most with Spark, with Python. And I think tomorrow my colleague from Muscat College, Ms. Hamida, will be discussing machine learning with Python. That's also a good part with the machine learning library provided by Spark. And if you are dealing with graph, of course, Spark can provide you that. So Spark works with various programming languages like Scala, SQL, Python, Java, and R. So we have plenty of available programming languages and scripting languages that you could use to access Spark. And the very good thing with Spark is that you can interface now Spark with visualization. Let's say you wrote an interface in Java. Let's say, for example, with the buttons and text boxes. You can now intertwine Spark with Java, and instead of displaying your result in a command line, you could display it actually on a real GUI for your end users. So to show an example, we have an example on how you read a JSON file. As I've told you, Spark is very versatile. You could also work with JSON files. And then you could perform a query, very similar with your SQL query, right? So this is the Spark SQL. Select, name, blah, 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 blah. And then you could execute this one and we'll give you the results later on. And then these results can be displayed into the command line if you want, or interface it or call it into the other programming language for better visualization. For the streaming, for the ML, for the machine learning, You can go with logistic regression. So my students are working with some predictions and forecasting. So this is a very good one. You could invoke logistics, okay? And then again, the first thing is your data set should be loaded into the HDFS, and then you could analyze it later on with the MO libraries available in Spark. So it's required that you have to install Python in the Linux environment. So Python is a separate installation, okay? It's not built in the Spark. So you have to install it separately, the Python programming language, and then later on invoke it in the Spark. And then also we have the streaming. For the streaming, you will see you could, as I've told you earlier, you could process data in real time. You just have to connect which server you want. Let's say, for example, Facebook or Twitter. If Twitter and Facebook allow you to access their server and get their data in real time, then it would be better. Then from there, you could perform analysis in real time, and then save your results later on into a separate file and store it in your HDFS. And if you want to draw some graphs, of course, you can go with this one. So, by the way, the default programming language of Python is Scala. Okay, the default programming language of Spark is Scala. And if you want to work with Python, then you have to install Python as a separate installation. So if you want to download or to get access with Spark, you can go with this website. If you will see, all of these tools in big data are within the Apache website. That's why the title of my topic is Digging Big Data. I mean, enough Apaches in digging big data, because Apache is the leading organization. It's an open source initiative, you know it, collaborated by various professionals and experts all over the globe. They're collaborating towards big data. So if you want to get it, you can go to this site. And the last part of my topic, my discussion, would be what lies ahead. We don't call them challenges, only opportunities. Although technologies have been developed for data storage, data volumes are doubling in size about every 2 years. And most companies, their concern is how organizations, how do they keep pace with the data and find ways to effectively store it. So the main concern of organization is that how could they filter out unnecessary data as it goes real time in their databases. So that's another good area for research actually. But it's not enough to just store the data, right? So data must be used to be valuable and depends on the curation. So protecting it again is another issue, and cleaning the data. So it's again another issue, another research. So data scientists, they say they spend 50 to 80% of their time curating and preparing data before it can be used. And lastly, big data technology is changing at a rapid pace, And I myself is really saying yes to this, because the server I've used last time were the latest ones, but this time I am 3 versions away. So you see how fast technology is changing. And the problem is that when you update one of the components, you have to update all, and it will be really challenging for administrators to do that. And I think I finished within the time, so 5 minutes before the time. So I'm done with my presentation, and the references are in this slide, this presentation, and the literatures in the references. And I'll be giving this to Dr. Santos and Dr. Basuda at the end of my presentation. So I am done. If you have questions to ask or any inquiries or anything to add, you are welcome.
Yes, sir. This is Dr. Vasudha
Thank you.
speaking. Thank you very much, sir, for your detailed and valuable session. As the title is Smart, Enough Apaches to Dig Big Data. Yes, sir, it's a complete session covering starts with big data, starts with data to wisdom, to data to vision to take data-driven decisions, even HDFS architecture and Java to MapReduce. And the real-life data sets from Kaggle also very clearly explains it. And the different resources, Apache Hive and Pig, and the complete flow through the resources for every tool to be used, the complete required resources you have been told us. And even a focused differences between Hive and Pig was very clearly explained, sir. We are very thankful. And finally, your session has ended with Spark tool also. And even from YouTube Live, we have got a lot of appreciation, sir, saying it's an awesome webinar, a nice presentation, and it's an effective presentation covering all the big data tools, sir. Not only from the participants, on behalf of the Department of Computer Science, GMRIT, and our HOD, Dr. A.V. Ramana, sir, we are very much, we share your, share our thanks for spending your valuable time, sir, for today's session. Thank you very much, sir.
Thank you so much. Thank you so much.
Yes, sir. Sir, if any, actually in the chat, we didn't find any queries, sir. Now the session is open for any queries. If anyone places your query in the YouTube live chat, I will be sharing it to speaker, Dr. Ferddie, sir. Just for 1 minute, we'll...
We changed the link for the YouTube, ma'am. Have you changed the link? Because I'm trying to access the YouTube link that you have provided me last time so that I could see queries.
Is it Santosh, sir? Can you share the YouTube link with the speaker?
Because I was really trying to read the feedbacks from the audience if there are some questions or clarifications. If I talk
yes, we'll share you, sir. We'll share you that complete live chat. We'll share you.
Thank you so much. Thank you so much.
We are sorry, sir. Why the link is not worked for you? We don't know. I'm watching, sir. I'm watching the full session. I'm watching actually.
It's all right, ma'am. Thank you so much.
Sir, can you please make Santosh Kumar sir as host? Sir, you have muted yourself, sir. Please unmute yourself and speak.
Okay, I have some comments here. It says, what about practicing with Horton Sandbox? Yeah, we have a lot of available online tools. Even Google is offering available tools for our students. This is actually for practicing and for academic purpose, but for deployment purpose, I suggest that we have to really practice the installation of the servers and the tools the way the documentations have provided. If you are planning to use them in the deployment phase, that's why in the mass level in Muscat College, I've installed the deployment versions of the tools, because when they go outside the industries they are working, they will not be working with this online environments, because of course they are expecting fees in the future, right? And also the visualization is our concern here. Let's say if your corporation wants to integrate your results into your, let's say for example, into your website or into your application, and then the challenge should be how we will connect these third-party softwares or programs to our corporate applications. That's why I suggest that we better install this the way the documentations are saying, for deployment, like a deployment purpose. Let me also read some questions. We can use Hadoop in Python. Yes, sir, you can use Python in Hadoop, but you have to do it in the Spark. And let me just see other questions. How to deploy big data in data science? So I think on the first part of my presentation, I have discussed to you the purpose of data science, right? Data science, the purpose of data science is to convert this huge amount of data into a useful decision, as we call it earlier, quoted by Dr. Masuda, data-driven decisions, meaning how do we convert this big data into gold, into a useful thing for decision making, what we call gold for the corporations. Because if they can draw very good decision makings, then innovation will be driven and they could achieve competitive advantage. Now, data science, what's the role of data science? As I've shown in the presentation earlier, data science requires skills, algorithms, techniques, and tools, and the ability to collaborate with the other fields like computer science and other areas for us to be able to achieve one common goal. How do we process this big data and convert it into a very useful decision-making product for corporations to utilize? And I think I have cited some use case in the discussion earlier, like fault detection, fraud, and product design, something like that. So those are the current trends in the researches, also customer experience and satisfaction. Let me get another one. Share the PowerPoint. Most of the audience are asking for the PowerPoint. Yes, I'll be giving the PowerPoint to Dr. Vasuda and Dr. Santosh. I think no more questions that I have. No more questions I have seen, madam, I think, on my side.
Yes.
Thank you so much.
You have answered for all the questions.
Yeah, thank you so much for the opportunity.
Thank you, Ferddie, sir.
Thank you, Dr. Santosh. Thank you for the invitation.
Okay, sir. Sir, a nice session, sir. Thank you for your informative session.
Thanks.
Sir, can you change that host to me, sir? The host privilege. Okay, sir. Okay, sir. So, dear participants, that feedback form is posted in your in the YouTube live. So up to 4:30, you can log into that YouTube live. So thank you, Ferddie, sir. You can, so if you want, you can leave, sir. Thank you.
Thank you so much, and see you soon. Thank you so much.
Sir, we'll expect the same cooperation in the future also, sir.
Thank you so much. Thank you so much.
Thank you, sir.
Santosh, please pick up the phone. Santosh, please pick up the phone.